lessons. Oh no. We're going to have a look at algebraic expressions and equations. Now, this is a really important part of maths, and it's going to be important all the way up until matric if you're going to choose to take maths. And so just getting these basics right is really important. Now, this is the part of the lesson where I really don't need you or expect you to write down the things that I'm going to go through now in terms of the terminology word for word. But it's important to know what these words mean so that when I say this is a constant, or we're working with a coefficient, you know exactly what I'm talking about. So this is maybe where your screenshot might become important. So you can take a screenshot and then you can look at it a bit later, but you'll see what sort of questions I can ask you with these words when we get into our first example. So let's just have a look at some terminology here. The first thing we're going to have a look at is what is a term. Okay, so terms are things that make up an expression. It's sort of like the words to a sentence. So if a sentence is a mathematical expression, all of the words are individual terms. Now, very importantly, a term is separated by a plus or minus sign. So anytime you see a plus or a minus sign, you know that it's separating terms. And when we start to simplify expressions, can everyone see the notes before I carry on?
Yes, that's what I'm asking. Can everyone see the notes? It's just on my screen. It's a little bit too small. So, but if they...
guys, sorry about my cat.
That's a cute cat. We like having the cats, yeah. Yeah, now I can see it. So, and I think I got so many responses saying that they can see it. Thank you.
Perfect.
Teacher.
Right, perfect, cool. So, when we start to simplify our expressions, we need to now start talking about terms, and we need to be very, very aware of like terms. Okay, now like terms are terms that have the same variable or variables and exponents. Now, when we get into our examples, I'll talk about these again, but we need to be able to identify like terms when we start to simplify. All right, so those are terms. Like I say, take a screenshot so that you've got it, but I don't expect you to write it down word for word. Okay, cool. So the next thing that we need to know is what a constant is. Now, a constant is quite easy to remember. The word constant means it never changes. So constant, or a constant, is a term that is just a number. So it's a number without a variable. So something like 7 or -5, if there's no variable, which is a letter attached to it, then that term is a constant. Okay, and the last thing that we need to know is what a coefficient is. So coefficients are generally the numbers that we see in front of a variable. So that's what I've got over here. So something like 3x, that 3 is our coefficient. Okay, it is a number that's been multiplied with the variable. And so we need to be aware of the fact that there is an operation happening there. But a coefficient is the number that we often see in front of a variable. Cool. I'll give you 2 seconds if you have any questions or if you need to take a screenshot, and then we'll have a look at how we would use these terms in questions.
Are we good, my people? Looks like we're good. No one is raising their hand or saying anything on the chats.
Okay, cool. So this is an example of the type of question we could ask you where these terms then become important. So I could give you an expression and then I could ask you some different questions. So let's have a look at what I've got going on here. So we've got this expression that I've given to you here. I just want to change from this pinky color. And we've got the expression 2x to the power 5 minus x plus 3x squared minus 7 plus 4x cubed. Okay, so remember we spoke about the fact that an expression is made up of terms, and we spoke about the fact that plus and minus signs separate terms. Okay, so anytime I see a plus or a minus sign, I automatically want to be thinking, okay, these are going to separate my terms. So the first question is asking, how many terms does this expression have? So based on what I've just said about plus and minus signs separating terms, in the chat, or you can raise your hand, I want you to tell me how many terms this expression has. Awesome, Vokile, well done. Everyone else, do we agree? Awesome, guys. Yes. Great.
People are on fire.
Yes, that's the best. Okay, so exactly that. There are 5 terms. If you can't see those terms, absolutely fine. Don't stress. We're going to practice. But essentially, each of those plus or minus signs separates our terms. So these are our 5 terms that we're working with. Now, remember, the sign in front of the term belongs to that term. So essentially over here, this minus belongs to that x. And that's quite important when answering these sorts of questions. But those are our 5 terms that we're working with. Okay, cool. So this term has 5. This expression has 5 terms. Right, the next question is asking you, what is the constant term of this expression? Now, remember, we said a constant term is one without a variable. And remember, I said to you that the sign in front of the term belongs to that term. So cool, I see we're going in the chats. Everyone put in their answers, what they think the constant term is. Cool, we're looking good. Right, I'm liking that we all can see that 7 is definitely an important part of this answer, which I definitely agree with. So we can see that the only term without a variable is the term that has a 7 in it. Now, remember I said that the sign in front of the term is that term sign. So we need to include the negative when answering this and say our constant term is -7. Okay, cool. So just remember the sign in front of the term belongs to that term. Okay, cool. The last question that sort of relies on you knowing that terminology and understanding what those words are would be something like, what is the coefficient of x cubed? Okay, so the first thing we want to do is we want to figure out, okay, well, which term actually has x cubed in it? Now, what we're looking for is the term that has that variable and that exponent. So we can see it's this one over here. So I see the chats are going, which I'm liking. I like what I see. Awesome, guys. Well done. So we know that the coefficient is the number sitting in front of that variable, so in front of the x cubed. And so the coefficient here would be +4. Now, if you put the plus, that's absolutely fine. That doesn't matter, but you don't need to. The only time it's really important that we put in the sign, is if it is a negative. Other than that, don't stress about a plus. Alrighty. Does anyone have any questions before we carry on?
People are doing so well. I'm proud of you guys.
You guys are ready for this term. Denzel, do you have a question or are you happy? Okay, cool. So that is the sort of question that you can be asked where understanding what the words mean is really important. But other than that, it's very rare that you're ever going to be asked, write down a definition for. It's more that if I use the word, you understand what it means. So you're going to see this now as we do the examples. I'm going to start to use these words, and so we need to know what they mean.
I'm sorry to Sam.
Yes.
Before we move on, Linzel has a question. Linzel, would you like to raise your hand, or would you like to put your question on the chat for us? Or you can, I think raising your hand will be way faster for teacher Sam. So you're more than welcome to raise your hand so that we can unmute you and then you can talk to us. Is that okay? Linzel, I'm gonna just unmute you just to see if you can communicate with us. There we go. Thank you for raising that hands up. I have sent you a message there. You will see, you just have to click on that button so you can talk to us. Are you winning, Linzel? There should be like a pop-up that comes in your computer. So you just have to click on it so you can communicate. Okay, so I think teacher Sam, you can continue and I will just be on the lookout for the question that Linzel has. Linzel, if you can please just put your question on the chat for us, that will be great. Thank you, teacher Sam.
No problem. Thanks, Denzel. Yeah, I've got the chat open so I can see if your question comes through. Otherwise, Yolanda is on it because she's awesome. Okay, cool. So we want to be able to simplify expressions. Now, the first thing you always want to do when you start to simplify, okay, so I'm going to just hang 10 here. Okay, Lindsay, what aren't you oh, okay, I'm going to start that sentence again. What aren't you understanding? Is it the words? Do we not know what the questions are asking? I need a little bit more so I can try help you. Okay, so
I think I'll take this one. I will talk to Linzel on the private message. Hey, Linzel, we'll have a talk and then Teacher Sam can continue.
Okay, cool. And then if you need me, just shout. Alrighty.
Thank you, Teacher Sam.
Thank you. Alrighty. So when we want to simplify expressions, the first thing we always want to do is we need to ask ourselves how many terms are in this expression. Now, to start off with, that won't be super important to get right straight away or to always do. But when we get to the more complicated simplification, we need to be able to identify our terms and make sure that we're simplifying our terms. So to start off with, we're always just going to ask ourselves this question. So quickly in the chat, if we look at the first question, x plus 4x, how many terms does this expression have? And remember, terms are separated by a plus and a minus sign, or a minus sign. Awesome. I'm liking what I'm seeing. Great, guys. So exactly as you said, there are two terms. I know there's two terms because this plus sign over here is separating my terms. And so my first term is that x and my second term is a plus 4x. Great. Well done. Okay, so now I actually want to simplify. Now remember, when we are simplifying, what is really important is or are like terms. I don't know how neatly I'm going to write. I apologize. Now, like terms, I said, remember, are terms that have the same variable and the same exponent. So what I mean by that is, if we look at this expression, both of these terms have the variable x in them, and both of these x's have the same exponent. They actually both have an exponent of 1. Now, because the variable and the exponent are exactly the same, those are like terms. Unlike terms would be something like 2x plus 4x squared. Even though those variables are exactly the same, they're both x's, the exponents are different. So here we've got an exponent of 1, but here we've got an exponent of 2. Those exponents are different, so these terms are not like terms. And because they're not like terms, it means we can't add or subtract them. If they are like terms, we can add or subtract them. Right, so in the first question, x and plus 4x are like terms, so it means I can add them together. Now, if you struggle with adding when we've got variables, don't stress, it's absolutely fine. My advice would be to draw like a little number line for yourself, especially when we start working with negative numbers. And you'll see that when we get an example, I'll use a number line. But what is really important to remember is that when we add like terms, the exponent to the variable will never change. Okay, so what I mean by that is, and just for sake of saving some time here, I'm going to type it out. So the exponent, if I could spell, of the variable doesn't change when we add or subtract. So when we want to add x plus 4x, the only thing I need to think about is how many x's do I actually have here? Well, if I've got one x and I'm adding another 4 x's, I've got in total 5 x's. And so simplifying this expression is just 5x. What's up?
So Vukile, I'm not sure if you're asking a question now. So I'm gonna just, is it fine if I unmute Vukile, teachers?
Good afternoon, ma'am. I found the answer for number 1 using a different method, because I said the coefficient for the first x is 1. So I said 1x plus
Yeah.
4x equals 5x.
Awesome. That's great. And that's perfect. And that's kind of what I was sort of saying anyways. We know that in the first term, we only have 1x, and in the second term, we have 4 x's. And so when we think about how many x's we have in total, we have 5 x's. That's absolutely fine. Tandi, are you okay?
So I think everyone is noticing that there's some writing going on, like on the screen. I don't know if you can see, but I'm not quite sure what's causing that. Like some drawing on the screen, like, you know, that yellow drawing there. I'm not sure if you can see it on your side.
I can. It wasn't me. So someone may be drawing on my notes here. I can't even take it off.
Access. I have to learn more because I don't know who's getting access to draw on your notes.
Okay, let's carry on and see if we have the same problem, and then we can hopefully try and see if a name comes up or something like that. Okay, so guys, if you see some drawing, just pop it in the chat if I don't notice.
Okay, perfect. Thank you.
Cool, Tandi, thank you.
Are you taking more questions or you want to move on? Because I have
No.
the line. And
Perfect.
The line.
Perfect.
We are all yours.
Hello. Can you guys hear me?
Yep.
Yes, 100%.
Okay. I just have a question. So when Limi, I'm going to use example 2, question 2 as an example of what I'm trying to say. Okay. So with question 2, if it was like 3x plus 2x, do we say, will it equal to 5x or would it equal to 5x to the power of 2? Like, I just want to know, like, when do we like make them exponents when we add them together?
Okay, cool. That's a really good question. So what we said earlier is when we add or subtract, the exponent never changes. The only time our exponent changes is if there is a multiplication or division. So using your example of 3x plus 2, because we're adding terms there, no exponent is going to change. So this is going to be exactly as you said, 5x. However, if the expression had been 3x times 2x, now we've got a multiplication. That is now where exponents come into play. So this is now where we need to say, okay, cool. We know that 3 times 2 is 6. But if we now go and consider x times x, we know that that becomes x squared.
Okay, I got it.
Okay.
Thank you so much.
Perfect.
Do we times like terms as well? I mean, unlike terms.
Okay, so we can times unlike terms, and that would be, if we sort of do another example, say, for example, something like x squared times x, for example. Those are unlike terms because the exponents are different, but it's fine because it's multiplication. So that can become x cubed. But if this had been x squared plus x, I can't do anything with that. It stays x squared plus x because they're unlike terms and we're adding or we're subtracting.
Okay, thank you so much.
Perfect, cool. Did we have another question?
Yes, so we have a question from Linzel. Linzel, I am clicking on your name. So if you can please unmute on your side. And if you still can't, you're allowed to just pop in your question on the chat, and we'll also be able to assist you, okay? Because I've been trying to unmute you, so you can try now. Just click on that little box that pops up there. Okay, so Linzel, I'm gonna skip you for now and just put your question on the chat. Okay, I'm gonna go to Tandi's back now. Tandi, we are all yours.
Hello.
Hello.
Hi. Okay, so I'm a bit confused by question 2.
Okay, cool. We're gonna have, so the 2x minus 3x plus 1.
Yes.
Okay, cool. So we're going to have a look at it together now. So can we do it together? And then if you're still confused, you can ask me a question.
Yeah, sure.
Awesome. Okay, cool. So guys, let's have a look at question 2. So remember, the first thing I said is tell me how many terms this expression has. So don't worry about anything else. only thing I want you to tell me right now is how many terms does the expression have? Awesome. Cool. 3 terms.
Well
So
done.
1, 2, and 3 terms. Awesome. Well done. Now, the next thing I want to ask myself is, do I have any like terms? Now, this, if you're someone who loves color, get a highlighter or get a Koki or a pen or something, and we can just highlight for ourselves like terms. So remember, a like term is a term that has the same variable and the same exponent. So would we agree that 2x and minus 3x are like terms because they've got exactly the same variable and exactly the same exponent? If you don't agree, okay, good, yes. Can anyone in the chat tell me what sort of term that +1 is? We spoke about these sorts of terms earlier.
So while they're busy answering, Linzel on the line. Linzel, I'm gonna try one more time, girl. Let's hope that it's gonna work. If you can try and unmute on your side. Other than that, like I said, I've sent you multiples of direct messages. There we go, Linzel. You can talk to us.
Hi.
Hi.
Hi, Linzel. If you can speak closer to your mic so we can hear.
Yeah, I'm using an audio. I don't have a mouse. Like, it's broken.
Linzel,
That's
I can't
okay,
quite
Linzel.
hear you.
Linzel, you can ask your question. Okay, go.
Linzel, try type it out for us.
Yeah, I think it's your network or something that it's giving you problems, but you can type your questions, you can reply to my direct messages, and we can take it from there.
Okay, cool. So back to what I asked is, what sort of term is that +1? Vukile actually wrote it out really, really nicely, saying that it's a constant because there is no variable next to it, which is awesome. There is no letter, there's no variable next to it, which means it's a completely sort of separate group to our x terms. The 2x and the minus 3x, those are like terms because they have the same variable and the same exponent. But that +1, that's completely different. So we sort of put it in another group. It's a different group of terms. We don't have to stress about it. So that's a constant. Well done. Now, remember, we can only add and subtract like terms. So when we now want to go and simplify this, I can only add together the things that are like terms. So I can only add together the 2x and the minus 3x. Now, this is where if you struggle with adding and subtracting negative numbers, a number line is useful. But also remember, you do have a calculator and you can just type it into your calculator. So if we think of it in a number line sense, and I'm just going to do a very rough number line over here. If we think of it in the sense of a number line, we're starting at positive 2x's. Now I need to take away 3x's from those positive 2x's, and then we just sort of jump. We know if we're taking away from something, we're moving towards the negative, so a negative infinity. And so if I want to take away 3, I just do 3 bunny hops in the negative direction and we get our answer. So if I've got 2x and I'm going to take away 3x, I'm actually just left with negative 1x. Now you can write the 1 there if you want, but if you just want to write this as a negative x, that's absolutely fine, completely up to you. And then remember, we said that this +1, that constant term, is completely separate. It's not a like term. So we just chuck it in there. We can't add or subtract anything to it, and that's it. Pulela, well done. Right, can I get a little smiley face if we're happy with example 2? Or thumbs up, thumbs down?
Yay, my people. Well done. Let's go. Let's vote for this. So remember,
Nice.
stand This will be also recorded, so you're allowed to rewatch it again. And remember, you're always allowed to ask questions, guys. Put them on the chat, raise your hand, and teacher Sam will clarify everything that we don't understand for us, okay? But well done so far, you are doing great. Remember, it's a new thing for us, so we are learning.
I was going to say exactly the same thing, guys. This is new, and this isn't, don't think this is just stuff that you must get automatically. Some of this is really hard, so it's going to take time, and we're going to figure it out as we go along. So don't stress, okay? Right, Tandi, I'm glad to see that. Well done. All right, so there's a lot of writing going on my screen right now, and some names are popping up. So if we can just try avoid whatever's happening. I'm not too sure how it's happening, but let's try not scribble on the notes as we go along. Okay, so what I'm going to ask you to do now is have a look at question 3 and tell me what the simplified expression would be. So I'll give you a couple seconds to go through that. Remember, ask yourselves, how many terms do I have? Which terms are like terms? And then go and add those like terms together. Don't worry. Right, if you're accidentally writing on the screen, don't stress, but let's not do it intentionally. Remember to use a highlighter or a color to get your like terms that you know exactly what you're working with. Okay, and then once you have an answer, pop it in the chat for me so we can see.
Let's go, my people. I can see that some of you are already giving some answers already. Let's pop them up. Let's go. More votes.
Right.
Votes. You're doing well, guys.
So I'm definitely agreeing with the 3 terms. Well done. So we know how many terms we have. So make sure you're identifying which terms are like terms. And remember, your like terms are terms that have the same variable and the same exponent. Right, so let's simplify that. I want you to go and add the like terms and get me an answer for a simplified expression. Okay, now if we have a look at our like terms, remember same exponent and same variable. So we can see we've got x squareds, which means that the minus 7x squared and the 3x squared are like terms, but the plus 4x isn't a like term because that exponent is different. That exponent is 1. So our like terms are the x squared terms and the x term. So we can only actually add together the x squared terms. Okay, I'm liking what I'm seeing. We're going to take a brain break now.
Man, you just see the time and you're like, brain break.
Until Melo's getting upset with me.
Okay,
we're getting there. Right, let's just finish this off so we can see that we've got our like terms now, and I'm really liking what I'm seeing in this chat here. 3x squared minus 7x squared, we're taking 7 away from 3, so I'm going to end up with a negative 4x squared. And then because that plus 4x doesn't have any like terms, it's just by itself, we just write it there, and that's our final answer. Okay, so I saw some of you were really close, and I think maybe it's just a little mistake. Some of you maybe put the wrong signs in. I saw 1 or 2. If you're not understanding where I got that answer, please make sure you ask. And then, yes, we're definitely going to take a brain break.
Tandi's on the line, so I'm just going to allow Tandi to talk to us. Hi,
awesome.
Quick question. If the answer comes out as negative 4x, and then you plus it with the 4x that's standing alone, do you add the whole sum, or you leave it like that because it's not a like term?
Awesome. Well done. You answered your own question. Excellent. So we're not going to add them together because they're not like terms. One has an x squared and one has an x. We can't do anything with that. So we leave it as it is.
Okay. Thank you.
Okay.
Sometimes
I see that
we have some quite few hands. Is it okay if they ask? I have
absolutely. For those of you who need a bit of a brain break, get up, stretch, move your body, and then let's hear some questions.
Hello, ma'am. Ma'am, from the previous question on minus 4x squared, why is it minus 4x squared? Shouldn't it be 4x squared plus 4x?
Okay, so let's have a quick look back to a number line. Obviously, if you've got a calculator there, you're more than welcome to use a calculator. I need to make sure I can count. If I think about my number line, I'm starting at positive 3x squared. So if I'm starting at a positive 3, I'm starting over here. Now I want to take 7 away from that. So I need to move towards the negatives. And if I'm taking 7 away, I'm going to do 7 bunny hops or 7 jumps. And so where I end up is actually at minus 4. And if you think about it, you've got 3 x's, but now you're taking 7 away. You're taking away more than what you have. And so that answer actually has to be negative because I'm taking away more than what I have currently. Does that make sense?
Yes, ma'am, it does.
Okay. Good.
Okay, so I have one more question from Dumelo. Dumelo, we are all yours.
Ma'am, I'm still lost. You.
Okay, where you lost? What is confusing you? What's tripping you up here?
No, ma'am, the whole question. Like, how did you get negative 4? Like the question, ma'am.
Okay, so if we look at the question, we saw that we had the like terms that I've highlighted there. So the 3x squared and the minus 7x squared, those are like terms. So that means I can actually go and subtract them. So I can go and say, well, what is 3x squared minus 7x squared? And that's what I've just done on the number line here. If I've got 3 and I'm taking away 7, I'm going to end up with a negative 4. And remember, we said that the exponent doesn't change. So that's why it stays x squared. But that negative 4 came from the fact that I started with 3, but I wanted to take 7 away. So I end up with a negative. The reason I then just have the 4x over there is because that's the bit in yellow. It's got no terms that are like terms with it. So I can't add anything to it. So it just stays as it is.
Yes, ma'am.
Does that make a bit more sense?
Yes.
Okay, this will come with practice. So we'll get there.
Yes, ma'am.
Okay.
Please.
I'm enjoying the joke. What's the hottest part in a room? The corner, because it's always 90 degrees.
That's a good joke.
Okay, everyone, if you haven't taken a little bit of a break, please do it. Get up, stretch, move your body, touch your toes, do some jumping jacks. If you've been able to tell me what your apples and your cherries and your bananas are, awesome. If not, have a little look.
Let's do this, guys. Remember to stretch. It's good for your body. I see some answers coming in, but did you say the final answer? Let's give Teacher Sam a final answer. Let's go, guys. Okay, it looks like Teacher Sam just went on some break somehow. Probably his network, so don't panic. She will be back. She will be back. She'll be back soon, guys. You guys are doing great, by the way. I'm proud of this class. You know, you're my favorite class. Yeah, Teacher Sam is back. Teacher Sam, when you logged out for a second, you still unmuted. If you could please unmute. There we go. Hello. And Teacher Sam is on freeze at this moment. Teacher Sam, we cannot hear you because I think your screen just froze for some reason.
Yes.
Now we're good. Now we're good, Teacher Sam, and your screen. That's all good.
Okay, right. So I don't know how much of that you heard. Apples 6, well done. Then we had bananas 4, absolutely. Cherries we know are 2, which I'm just going to write next to it there. Now, if we know all of that, and if we have a look here, we need to be careful. There's only 3 bananas here. So if 4 bananas is 4, each banana is actually 1. So this represents 3. So if I've got 2 plus 6 plus 3, do we all agree that that is 11?
I see Asam Globe has agreed with you, saying it's 11. Well done.
Awesome. Cool. And guys, these, like, if you don't get these, or if you don't get to completing the whole thing, don't stress. It's just for your brain to take a little break from what we're doing so that it doesn't feel tired when we're done. Okay. Are we ready? We're excited. We can do this.
Sandy, I see that joke over there. Your algebra.
You guys are going to get a lot of math jokes from me. Alrighty, guys, let's do this. Who can tell me how many terms are in English? How many times? I'm going to start my whole sentence again. My brain is fried. Right. Okay. How many terms are in this expression?
Let's go, my people.
Yes, awesome. 4 terms. Well done, everyone. So we can see that because we know our plus and our minuses separate our terms. So those are the 4 terms that we're working with. Now we want to simplify. Now remember, we want to identify our like terms. So grab a highlighter, grab a color, do what you want to do. But let's identify our like terms. So like terms, same variable, same exponent. So we've got an x to the power 4 and another 2x to the power 4. So those are like terms, same variable, same exponent. We've got another group of like terms, which are the x cubed terms of negative x cubed and minus 2x cubed. And that's because same variable, same exponent. Now I can add my like terms together. Now, if you need to, you can rewrite the expression to put the like terms together. That's going to help you be able to add and subtract. Go for it. So if you want to group your like terms to say 2x to the power 4 minus 2x to the power 4 minus x cubed minus 2x cubed, that's absolutely fine. If you need to group your like terms together before you add and subtract, go for it. Whatever's going to make your life easier. But now we're going to add and subtract. So 2x to the power 4 minus 2x to the power 4. Now let's just think about this carefully. If we are going to subtract the same thing, so if I had 3 minus 3 or 5 minus 5, what happens when I subtract something from itself? What answer do I get? Right, awesome. So we get 0. If I take something away from itself, it's 0. So 2x to the power 4 minus 2x to the power 4 is actually just 0. They fall away. They cancel each other out. You don't have to write the 0 there. I'm just putting it there to remind us that that has simplified to 0. Then we go to our x cubed terms. What is, and if we need to remember there's a 1 there, what is minus 1x cubed minus another 2x cubed? And again, if you need your number line, draw a little number line for yourself. If we're already at minus 1 and we want to take away another 2, where do we end up? We end up at minus 3x cubed. And so our answer is actually just that minus 3x cubed. We won't have an x to the power 4 term because remember it becomes 0. And 0 minus 3x cubed is just minus 3x cubed. Okay, so that was a bit of a tricky one. So take a second, make sure that you're understanding. And if you have questions, let me know.
Question, it's your time. And if you do understand it, let's see thumbs up on the chat. Like this teacher Sam can be convinced that we understand. Okay, guys. Yes, Thunder, well done. I see you. Yes, Katlisa. Woo, my people are on fire.
Two thumbs up. Is that all we got, guys?
Guys,
it's okay to tell me that you're struggling. It's absolutely fine.
Tumelo is also fine. Ukanyo is also fine. Nseki, you are fine. Oh, wow. Well done, guys. Jada, fine. Nathaniel also saying, me too, ma'am. He's fine. Lauren's fine. Tandy, fine. You guys did well. Well done.
Awesome. Well done. Okay. So let's have a see at this question 5. Now, what I want you to be careful of when we look at this question 5 is remember like terms are terms that have the same variables and the same exponents. So my first question, how many terms are in this expression?
Keep them coming, guys. I see them.
Awesome. Awesome, guys. So 4 terms. 1, 2, 3, 4. Okay, great. Now we want to find our like terms. Now, before we do that, I want to ask you a question.
Teacher Sam, so your screen has froze. So it's probably network problem. We cannot hear anything anymore. MTS has a joke for us while we wait for Samantha. MTS said, why are obtuse angles so depressed? Because they're never right. That's the funniest joke ever. Thank you, MTS, for sharing that with us. So guys, we can still see that, like the question, right, on the screen. So we have okay. So the screen just disappeared, and I think Teacher Sam will join us soon, but reflect on that joke, okay? Because I really think it was funny. So everyone, you are allowed to ask questions so far if you didn't understand. So thank you, Nathaniel. Thank you. So guys, remember the sum that was on the screen, right? It had 4 terms. So if there's anyone amongst you who doesn't really understand why did we get 4 terms, please raise your hand or let me know on the chat. MTIs, I'm happy that your parents won't look disappointed when you say that. They won't. It's a good joke. It's really a good joke. I liked it. And guys, you're doing so well, by the way. I'm so proud of all of you. And remember that this lesson is recorded. I'm repeating this again. So after 24 hours, you will see it. If you are really, really struggling, maybe watching it the second time, you know, when you're relaxed or eating or whatever, maybe it will sink in slowly, okay? Because some of this is actually difficult to get. But I know you guys are my clever class. You are my intelligent babies. Guys, well done. Yes, Nathaniel, the plus and the minus is separating the terms. That's why we have 4 terms on that sum that was on the screen, okay? So I'm just looking whether teacher Sam is going to be back with us soon, or she's not. But so far, so good, guys. And I think that what you can do, because you've already written, so I've been so naughty, I didn't write my sum down. So if you did write your sum down, I would like you to add those like terms together and give us a final answer. So someone can actually raise their hands and present it to us. What was the final answer? Okay. So you are more than welcome. Nathaniel, do you want to jump in over here? Also, you have a joke. Why did the obtuse angle jump into the pool? Because it was over 90 degrees. Guys, where did we get these jokes? Busiso says that today he understood everything. Oh, I'm so proud of you, Busiso. Sending my hugs to you. You should tap yourself at the back and say, well done, I did well today. MTS, let's focus, guys, on solving that question for us, okay? Is there anyone who has the question written down so that they can give it to me? Like this, we can solve the question before we can do the poll. It's a poll day today. Hatli, so do you want to raise your hand and help me out with the question? That would be nice. Like this, we can just finalize the question and wrap it up because we have time. Okay, so raise your hand and let's do this as fast as we can. There we go. Thank you, girl or boy. Hi.
Hello.
Hi, so what was the sum again?
The sum was 10x to the power of 3.
Yes.
And then you say plus 10.
Yes.
Yx to the power of 3.
Yes.
Then it's plus 3x to the power of 3 y.
Yes.
Then minus 4x to the power of 3.
Okay, guys. So we had 4 terms, right? And if you did write it down, you can see that the 10x to the power of 3 with minus 4x to the power of 3 are like terms. And yuppie, guys, look at Teacher Sam is on the line. Hi, Teacher Sam, you're back with us.
Guys, I'm very sorry. I don't know what happened. I think I've got it working now. I apologize. I'm hearing though that we're going through the question, so by all means carry on.
Okay, yeah, so we were busy just combining all the like terms. So if you can from there and just highlight for us the like terms, and then we can find a final answer like this. We can do the poll before we wrap it.
Awesome. Okay, cool. So our like terms here, we've got the x cubed terms, and then hopefully in my absence, we are all in agreement that even if an order is mixed up, as long as the letters or the variables are exactly the same and their exponents, they're still like terms. So here, even though the x cubed and the y are swapped, it doesn't matter. It's still a like term to x cubed y. And because then we've got our like terms grouped together, we can add and subtract. Remember, again, if you need to write them grouped together for yourself, that's absolutely fine. So we've got 10x cubed minus 4x cubed, and then we've got the minus 10. And here, if you want to write the x cubed first and then the y, that's fine. Really doesn't make a difference. Plus 3x cubed y. And then we can add. So 10x cubed minus 4x cubed is 6x cubed. And now negative 10x cubed y plus 3x cubed y is a negative 7x cubed y. Remember, none of the exponents are changing. It is just the coefficient or the number in front of those variables that changes. Do we agree